Hey everyone, Andrew here with the Imagine Academy, and in today's video, we will be demonstrating the full scan and design workflow for a single unit implant using the Medit i700, Imagine's MIST intraoral scan body, and the exocad design software. So let's get right on into it. The first thing we're going to want to do is make sure that our Medit Link software is open and fully updated. In order to complete our case setup, we're going to want to be in our case box over here on the left-hand panel. And we're going to click New Case in the upper right-hand corner. I'm going to start out by typing in my patient name. In this case, we're going to be doing a single unit on number 30. So I'm just going to name it number 30 implant crown. Okay, and then we're going to select Register and Scan. From here, this is our case setup. So we will be filling out all of our form information. First thing I'm going to do is I'm going to go over to tooth number 30. I'm going to left click and I'm going to select implant crown in this case. We're going to be doing a screw mentable crown. So I'm going to select screw type. And then we're going to be milling it out of zirconia. And for our shade, I'm just going to be selecting A1. Okay. Once our case setup is complete, we will see our order list over here in the bottom right-hand corner, and we just want that to accurately reflect the restoration that we're going to be scanning and designing. So once I confirm that everything here looks okay, we're going to go up here and select Scan. This will prompt our Medit Scan for Clinic software to open up. Once our Medit Scan for Clinic software opens up, we should hear that chime sound indicating that our scanner is connected and ready to go. Another way to ensure that it is connected is to expand the panel on the left, and you should see a green check mark on the bottom saying ready to go. We also want to make sure that our scanner is fully calibrated and that we have a clean, sterilized tip on. Before we actually get into any scanning, there's a couple things that we want to go over. The first is going to be our general scanning checklist. So kind of going down the line, we want to first make sure that we're avoiding any external lighting source. We want to ensure that the mirror on our tip is clean of any stains or smudges. We want to make sure that our scanning area is completely dry. So make sure that we have no blood or saliva in any of those important areas that we're going to be scanning. And then lastly, we always want to make sure we maintain an appropriate distance from our teeth with the scanner. Once we've gone through our entire checklist, the next thing we want to do is make sure that we have all of our proper scan stages. For this specific case, we're going to be starting out with our mandibular scan. Then we're going to be doing our opposing for the maxilla, then our occlusion, and finally ending with our scan body. So this is accurate for what we need. First thing I'm going to do is I'm going to click onto my mandibular scan and make sure that it is highlighted, indicating that that's the correct step which we're about to scan in. From there, I am going to be separating my models just for sake of ease. But we do want to take into account certain restrictions of the patient, such as how much they can open their mouth and where their cheek and tongue is. This kind of ensures that we use proper scanning technique and proper path in order to get our complete scan. So what I always want to do is I'm going to grab my scanner, and I always want to hold it with a pen grip from the bottom, which allows for more dexterity during scanning. We always want to actually take our scanner and place it into the patient's mouth right over top of the tooth that we want to scan before starting our scan. Usually I always like to start on the occlusal surface of the molar because we have a lot of cusps and grooves and anatomy, which is very easy for the scanner to pick up as opposed to the smooth surface of like the buccal. So again, I'm going to take my scanner, I'm going to position it right over the molar, and I'm just going to do a single tap to start my scan. You can see that immediately we have our sound playing for our scanner, and we also have our visual cue in the green rectangle in the center. Both of these things are just ensuring and letting us know that we are on track and that our scanning is optimal. So again, I'm going to start by hovering over the molar, and we're going to scan our entire occlusal surface first while implementing a rocking motion for our anteriors, allowing us to pick up not only the incisal edge, but a bit of the buccal and lingual too. And what this occlusal scan allows us to do is to build up our main scan data, and then we can easily stitch our buccal and lingual to that main data scan. From here, I'm going to rotate 40 degrees to our lingual, and I'm going to scan in our lingual surface. While doing this, it's important to not be looking into the actual patient's mouth and to pay attention to our live view window in our bottom right-hand corner, which is a live perspective of our camera. Once we've scanned in our lingual, we're going to rotate over that molar that we started on, and we're going to scan in our facial. Okay, so once we've completed our main scan path, it's important to double check our scan and to make sure that we filled in all the important areas. So again, I'm just going to rotate my scan and check it from a couple different angles. Most importantly, what we need is our implant site, especially our emergence profile of our tissue, and then our interproximal contact areas, which we do see we are missing a bit of data, so we're going to want to go ahead and fill that in. When adding additional data, it's always important to start your scanner on an area where you already have common data, which will allow the new scan data to properly stitch. So I'm going to take my scanner, I'm going to position it in the patient's mouth right over that second molar where we already have some data, and I'm going to start the scan. From here, we really just have to use different angulations to capture those contact areas. So in this case, I'm going to approach it from the mesial side, and then the distal side for my molar. Okay, I'm going to double check one more time that I've captured all our important areas, which in this case we have. If you want to double check to make sure that you have a nice reliable scan in that area, we actually can change our display mode to our reliability map, where we should see a nice green, bright green color in all of those important areas, especially over here around the number 30 site, which in this case, everything looks good. So I feel confident moving over to the next step. From there, we're next going to be scanning our opposing model. So I'm going to want to make sure that my maxilla scan stage is highlighted in blue. And then we're going to repeat the same exact scan path as we did for our lower model. So I'm going to grab my scanner. I'm going to grab my maxilla. Okay. And we are going to be starting out on our occlusal surface of our second molar. Here, we're going to actually be using the reliability scan display mode so that we can see where the data is transitioning from green to red, where all the green data we know is reliable and we can feel comfortable processing that data and sending it off to the lab. Again, I'm paying attention to my live view window, trusting my visual and audio cues to ensure me that I'm scanning the proper data that I need and that my scanner is actually capturing information. Okay, once I've built up my main occlusal data, then we will rotate 40 degrees to our lingual, and we will start to capture our lingual. Okay, once we've captured our lingual, we'll rotate 40 degrees over our molar to our buccal surface. Okay, once we're done our opposing scan, again, I'm just going to double check my model. What we're mainly looking for is that we have good data on the buccal side of our posterior, which will be used to align our occlusion, as well as our occlusal data on our occlusal table. So I can see maybe I'm missing a tiny bit on the posterior of the buccal, so I'm just going to go ahead and add a little bit more. All right, that looks good to me. From there, we are then going to move to our occlusion stage. So I'm going to re-articulate my models here. When it comes to doing our occlusion scan, it's important that for full arches, we're always scanning both the left and the right side of the patient. If this were only a quadrant, we would only require us to scan one side, meaning we're only going to be using one of the two occlusion scan buttons here at the bottom. Again, we have our first occlusion and second occlusion. That doesn't correlate to left or right. It just means one side and then the other side. So what I'm going to do is I'm going to take my scanner. While the patient's open, we want to insert that scanner by the cheek and then have them fully shut and make sure that they're fully closed. Once the patient's closed, I'm going to position my scanner over the facial of my second molar. I'm going to start my scanner. And I'm going to implement a zigzag motion, picking up 3 to 4 teeth as well as the gingiva. Once our alignment is complete, you can see that it turns a green color, indicating that it has been fully aligned to our occlusion scan. From there, we'll stop the scanner. We will click over to second occlusion, and we'll repeat the same process on the other side. Here, our software is just optimizing our scan data just to make sure that everything is properly aligning to each other using best fit matching. Once fully optimized, again, we're going to double check our occlusion scan. A good way is also to flip over to the intaglio surface and make sure that none of our teeth are sticking too far through our opposing model, which in this case, everything looks accurate to what I see on my actual model. The last step in our scan process is actually going to be to scan in our physical intraoral scan body. So what I'm going to do is I'm going to make sure that my scan body stage is properly highlighted, and we can see that our mandibular scan that we originally did is actually copied over to our scan body stage. So that now all we have to do is actually fill in our missing data for our physical scan body. So here we have our missed intraoral scan body. These scan bodies are typically shorter and have a much more narrow profile compared to a standard model scan body that you would see. Our scan bodies also each have a flat side, which is indicative of our timing indicator. So when placing our scan body into the patient's mouth, we always want to make sure that our timing indicator is faced either towards the buccal or the lingual of the patient. That way our interproximal contact areas aren't interfering and we can properly align our STL of our scan body in our exocad software. So what I'm going to do is I'm going to take my scan body. I'm going to position it so that my timing indicator is facing towards the buccal, and I want to make sure that it properly clicks into place. From there, we're going to take our driver and we're simply going to tighten in our scan body. Okay, we just want to make sure that our scan body is properly in place, it's not moving, okay, and that it's fastened tightly. We actually recommend Imagin's missed intraoral scan body versus traditional scan bodies because the missed intraoral scan body's narrow profile actually ensures full seating even on subcrestal implants, unlike traditional designs that may interfere with tissue. This is key for accurate, immediate, and provisional restorations at the time of implant placement. Also, additional flared scan bodies often struggle to seat properly on subcrestal implants, risking poor engagement with the implant's internal connection. In contrast, the Miss iOS scan body's narrow profile enables accurate, full seating immediately after guided implant placement, supporting ideal restorative contours and reliable outcomes. Once our scan body has been fully seated and tightened, we're ready to go ahead and scan it in. So you can see I'm already on my stage for my scan body. So all I'm going to do is I'm going to take my scanner, and similar to how we've been doing, I'm going to take it and position it over an area of common data that we already have, in this case our second molar on the occlusal surface. We're going to start our scanner and proceed to actually scan in our scan body, trying to get as much information as we can. But again, the main things we're focused on is going to be our depth indicator, which is the flat portion on the top, as well as our timing indicator, which is our flat wall on our buccal surface. Okay, so once we're done scanning, we're just going to double check to make sure that we've captured all the proper areas that we need, which in this case, you can see we've captured our flat wall for our timing indicator, as well as the top of our intraoral scan body. Once we've completed our scan body scan, that is pretty much it for our scanning process. We've ensured that we have all the proper data, and the last thing that we're going to do is complete our case by selecting the check mark all the way on the right-hand side. We have three options when it comes to processing. The first is going to be to leave it as is, meaning do not fill in any holes. The second would be to fill in any major holes. And the third would be to add a base for a printable model. In this case, since we already did make sure that all of our important areas were filled in, we can just choose to fill in all the remaining smaller holes that we have, just so we have a nice, more complete scan. You can see that our Medit Scan for Clinics program is going to actually save our case and close out of the program and then bring us back to Medit Link, where our raw data is going to be processed into our STL files that we will then be bringing into exocad. So we can see here at the top, it says that our data is processing, and we're simply waiting for this circle to fully full up, where then it will say scan completed, and we'll be able to view our files in the file viewer. As you can see, our scan has been fully processed, and we now have the scan completed designation at the top, which is allowing us to see our fully processed and high definition scan in our file viewer. Again, we just want to double check that everything looks proper before we actually let the patient go, right? Ensure that we don't actually need to add any additional scan data. Everything here looks good to go. So the last thing we would actually need to do in Medit Link is to export our STL scan data for exocad. In order to do that, we have our export button here in the upper right-hand corner. So I'm just going to go ahead and I'm going to select that. And if you want to choose specific files in our file list, we can check which ones we need. In this case, I do want to include all of the scans that we have captured. Secondly, we're just going to choose where to save our scan. I'm just going to save it to my desktop here. And then we want to choose our mesh format. In this case, I only need PLY, which is going to be our color data for the exocad software. From there, I'm just going to select export. And now if I open up that folder, we can see all of our scan data here ready to go. Now that our scan process has been completed and we have exported all of the files we need for designing, we're now going to be using the new 3.3 version of exocad to do an AI-assisted design of a single unit implant crown. So I'm just going to go ahead, I'm going to close out of here. I am going to open up my exocad software. And we're currently looking at the database for the new 3.3 version. When creating a new case, obviously first we're going to want to go ahead and select new case at the top. And we're going to want to fill out our client and our patient information. For client in this case, I'm just going to be using default. And for our patient name, I'm just going to be typing in our number 30 implant crown. Okay, once I have that information filled out, I'm next going to go over to my actual work order form and choose tooth number 30 here. Okay, and we're going to be designing an anatomic crown. For our material, we're going to be just choosing zirconia. And then we are going to be doing a screw retained crown. Okay, once we've selected screw retained, it's important that we have scan body scan selected. This is going to basically tell us that we have a separate scan body scan that we use in our intraoral scanning software, and that our scan body isn't actually part of our main scan. What's nice is because we use the MIST iOS scan body, it enables flexible full spectrum implant restoration design in exocad. It supports in-house or outsourced production of custom abutments, screw-retained crowns, and titanium bars. By exporting the implant interface with the prosthetic design, MIST offers true design and manufacturing freedom. After we've selected scan body scan here, we just want to double check to see that we have everything else labeled appropriately. In this case, we are not going to be copying or mirroring, and we always want to pull to our margin. So everything in the setup looks appropriate. I'm going to go ahead and select OK. And then I'm actually also going to mark our immediate adjacent teeth. Okay, once I have that all set up, we want to just make sure for our scan mode, we have it set up as 2 stone models in occlusion, which will allow us to import both our working jaw and our opposing as well. The last thing we're going to want to do before actually going into our design is save at the very top. So once we select save, it'll actually prompt this open and explore button to be accessible at the bottom. If we go ahead and click this, it'll actually open up the specific folder related to the patient that we created. It's good practice to actually take those exported files from Medit link and to copy all of those files and paste them into our patient specific folder. Just like that. Once those have been pasted in, you'll actually be able to see a 3D preview of your scan in the bottom left-hand corner, indicating that you've properly added those files to that folder. Once that's done, we can go ahead over to our right-hand side for our actions. And in this case, we are going to be doing an AI crown design. So I'm going to click AI design. You can see that it has prompted our dental CAD software to open up, which is where we're going to be completing our actual design. Because we've already imported those STL files into this specific patient folder, we can see that it has directly opened us to that page with our files, so they're easily accessible and we don't have to go searching through our local PC to find our files. You can see at the very top, it's asking us to load our lower jaw scan first. So we're gonna go ahead, we're gonna find our lower jaw, and we're going to click open. Next, we're going to be loading in our scan marker. So I'm going to go ahead and find my marker file and click open. And then lastly, we're going to be importing our opposing scan, which is going to be our upper. Okay, so this is our wizard for our design. You can see that in the bottom left-hand corners, we have a series of steps that we're going to follow in order to produce our final restoration. First thing that we always want to do is adjust our scan data orientation. So we're just going to orient our model as if we were looking from the occlusal surface. We want to make sure that we're not seeing any red on the intaglio. Okay, it doesn't have to be perfect, but just get it as best as you can, and then select next. Once our AI crown design wizard step fully opens up here, we can see that we have a couple options in terms of style. The first is going to be to do an auto detect. The second will be to use adjacent or contralateral. And then lastly, you can pick an existing tooth library within exocad for the software to use. In this case, I like to use the auto detect feature. And then under parameters, we do have a couple options in terms of spacing to our antagonist and our adjacent. But again, I'm going to be leaving all of these at default. So under submit, we just want to make sure we have auto detect selected. And then we're going to request our cloud calculation. Here, we just have to confirm and agree to use our cloud-based AI design. So I'm just going to go ahead and say yes. And it should take approximately from 60 to 90 seconds for the AI program to design your crown. So once our AI crown has been fully generated, we're going to want to just double check our proposal. So I'm just going to go ahead and turn off my antagonist and just double check the positioning of my crown relative to my opposing and my interproximals. Overall, I'm happy with the proposal. So what we're going to have to do is first rate our design on a scale of 1 to 5 stars. So I'm going to rate it 5 stars. This will help with future AI proposals that you generate. And then we have 3 options. I'm going to be clicking the first one, which is just saying I'm happy with the result and that we want to continue with the fast workflow for a crown design. So once we finish the actual AI portion, now we're essentially just going into a standard crown design for a single unit implant. The first step in our wizard for our actual fast crown workflow is going to be to detect our implant position. It's important that we locate the proper implant libraries from either exocad's website or directly from the manufacturer and add them to the appropriate dental CAD library folder in exocad. Once those have been added, we'll be able to see the full list of our implant files here. So in this case, we are actually going to be using the MIST KP iOS long scan body, okay? So I'm going to select that prosthetic component. Next, we're going to have to be choosing whether we're going to be doing an S-link or an L-link. In this case, I'm just going to be doing the tallest length, which is going to be a 5.3 L-link. And lastly, we're going to have to choose our fit, which is going to be essentially our cement gap in this case. The standard typically is going to be 0.034. Okay, once we've selected our prosthetic component, you should see a 3D image of that component over here in the left-hand side. And essentially that should match up with the shape of your intraoral scan body and specifically the timing indicator. We can see that we have a red dot on that flat wall. So while holding control on my keyboard, I'm going to select that same spot and just left click. We can see that right away, our library has done a matching based on our color map, right? So we just want to ensure that we have a nice overlap in this blue color between our scan and our implant file. What's nice to kind of bring up right now is that because we're using the MIST iOS scan body, we actually have the ability to easily change the height of our component. So if we realize that, maybe the 5.3 is too tall for our crown, we can simply then switch it to a 4.0 height, which would essentially be the equivalent of cutting that component down. And if we switch it, and we make our scan body translucent, we can now see that our component is actually much shorter as opposed to before. In this case, we're actually okay. We're just going to stick with the 5.3. So I'm just going to be using that in this case, which you can see in this case is slightly taller. Okay, once we've matched up our implant position, we're then going to select next. Okay, and we have the step to define our emergence profile. Really, the only time we want to mark our emergence is going to be when we're designing a custom abutment. When we're designing a screw retained crown, like in this situation, we're actually going to be skipping our emergence profile. That way our crown adapts directly to the seating area of our implant. So I'm just going to go ahead, I'm going to select next. And after that, we have our abutment bottom step. Again, since we're not actually marking our emergence profile, we're not going to be contouring our abutment bottom. The only thing to consider is possibly reducing your profile height border. So I'm actually going to lower that down to 0.1. Okay, so that's all we're going to do on this step, and then we're going to select next. We can see now that our crown has fully adapted to the seating area of our implant, which is exactly what we were looking for. Once that's been done, we're now in our free-forming step where we can make the final fine-tune adjustments to our crown before finally merging and saving the restoration. So typically when in free-forming, I always like to start in the anatomic section. In anatomic, I'm able to push and pull certain areas of the crown, and my different presets here just correlate to different areas of interest and how big that area is that you're pushing or pulling. Before I'd like to do anything, I do want to go ahead and turn on my adjacents and also to include healthy teeth on my show distances tab. From there, again, I'm going to start in anatomic, and typically the first thing that I'm going to want to do is just ensure that my contact areas are nice and broad, which in this case with the AI design, it actually did a pretty good job of giving us a slightly heavier contact. That way we can actually adapt it and then smooth it out in the next step. So nothing we really need to do for our interproximal contacts. Next, I am going to check the overall position of my cuss tips. Right, which in this case, they look okay. Maybe I'm just going to go ahead and lower these down a tiny bit. All right, that looks good to me. Next, I'm going to go ahead and double check my marginal ridges. So I'm just going to zoom in. Again, check my ridges. There shouldn't be too much work that needs to be done here because, again, we are using that AI crown design, which is taking a lot of these design parameters into consideration. Okay, I'm pretty overall happy with the anatomic placement of all my regions. What I do want to do is I'm actually going to go to free, where I can use my add remove tool to actually add a little bit of material and add a little bit more contour to the bottom of my crown. We just want to make sure we have enough of material, that way it's nice and stable and secure and a strong implant connection. Once I've added, I'm just going to go ahead and kind of smooth out that transition. Okay, keeping in mind how much pressure I have on my gingiva as well. Okay. From there, once I've kind of added material and I contour that crown a little bit better, I'm actually going to go back to my anatomic tool. I'm going to lock the position of my cusp tips, and I'm going to go to tooth parts to make my crown slightly less bulky. Okay, overall, I'm happy with that overall position and shape of my crown. The last thing I'll do is I'll come back to my free and I'll just kind of add material anywhere that I want additional contacts on my crown. With adding material, whenever we go to adapt, it'll actually cause the crown to have more of a worn out look if that's the goal that you're trying to achieve. But again, I'm happy with my occlusal contacts and I'm happy with my interproximal contacts as well as the overall shape of my crown. Once I've done all my fine tuning, the last thing we're going to do is go over to adapt, where we're first going to adapt our static occlusion to 0.1 millimeters, as well as adapt our approximal. A nice tip for our approximal is if we click the drop-down menu here, we can actually choose to block out our adjacent teeth, which will block out our adjacent teeth directly at 0 degrees and give us a nice broad contact area. Additionally, we can see that if we were to adapt our approximal now, it would actually cut away this bottom portion that the software is mistaking for our interproximal contact. So I'm actually going to choose to exclude selected parts. And then similar to Microsoft Paint, I'm just going to kind of paint over those areas that we want to exclude. Okay. Once I've excluded all parts, I'm just going to select approximal here and adapt it down to 0 millimeters. Okay, once that's done, I'm going to turn off exclude selected parts. I'm going to turn off my show distances tab and I'm going to go over to my smooth flatten tool just to really smooth out any bumps or divots that we might have from our adaptation. Be cautious that when smoothing out, it is going to add a little bit of material back. So then we always do want to turn back on our show distances tab and just double make sure that our contacts are broad and heavy enough for our liking. Okay, that all looks great. And then lastly, we're going to double check our occlusal table. Again, I'm going to turn off my show distances tab. This time, instead of doing a standard smooth, we're going to be doing a shape preserving smooth by holding control on our keyboard and smoothing over our occlusal table. Okay, once our adaptation step has been completed, that is the majority of everything that we need to do in our freeforming step. So from here, I'm going to click next. Okay, and we go straight to our screw hole design. We can see that based on our implant position, we could see exactly where our screw channel is going to be coming out of. We do have the option to switch protection on and off. If our screw channel is going in through an ideal position, then by all means, we want to turn that off. So it's just punching out an exact hole for our screw channel, as opposed to a screw channel that's going in between two teeth or in between the teeth and the gingiva, in which case we would want to turn on the additional protection. So I have this turned off. I'm going to click next. You can see it punches out my hole for my screw channel. And just like that, we have a completed single unit crown using the AI feature in exocad's new 3.3 version. In order now to access our actual STL files, we just want to make sure that we have I'm done checked off, as well as save scene in project directory. We do have an option to actually design a model directly from here if you want to check the fit of your crown, but in this case, we don't actually need to do that. So we're just going to make sure we have I'm done selected and click next. You can see that it then is going to close out of our dental CAD software and bring us back to our DB. To easily access our scan files, again, we're going to be utilizing our Open and Explore button right here, where once I click that, you can see that now our STL file along with our construction info file are all readily accessible for us. It's important that you always include your construction info file with your STL because that incorporates a lot of our positional data that then will be applied to the mill or printer. At this point, once you have access to your files, you can just actually send that to your own mill for manufacturing, or you can send it off to a different laboratory to get your crown processed. All in all, choosing the correct scan body shapes your entire digital workflow and expands your restorative options. The MIST iOS scan body stands out by offering complete flexibility. You can work with any lab, access the full range of implant designs, and utilize advanced features like angled screw channels and printed models. Best of all, it lets you export the exact implant interface from your exocad design, enabling precise custom manufacturing either at Imagine's milling center or your own lab. This means you can deliver the perfect personalized prosthesis for every patient. Thank you for taking the time to watch our video and stay tuned for more content to come.